This is section 5.4, write linear equations in standard form. So a linear equation of the form ax plus by equals c is in standard form. And all linear equations can be written in standard form. Notice this time I didn't say non-vertical, so we will talk about vertical and horizontal lines. But remember, we also already know two other forms for linear equations. So we know slope-intercept form, y equals mx plus b. And we also know point-slope form, y minus y1 equals m times x minus x1. And so standard form is just another way to write linear equations. Okay, so given an equation in standard form, we can write equivalent equations. So looking at this one, 2x minus 6y equals 4. One thing we could do to write an equivalent equation is we can multiply by 2 on both sides. So remember, an equation stays the same as long as whatever you do to one side, you do to the other. So 2 times 2x minus 6y equals 4 times 2. Well, we got to distribute, so that becomes 4x minus 12y equals 8. So that is an equivalent equation, still in standard form, because notice x and y are on the same side of the equal sign. But looking at 2x minus 6y equals 4, notice that those are all multiples of 2. So I could actually either multiply by 1/2 or divide by 2 on both sides. Remember, it stays equivalent as long as whatever I do to one side, I can do to the other. So if I divide through by 2, I'm left with x minus 3y equals 2. Now, to prove to you that these are actually equivalent, what I want to do is put these into slope-intercept form and show you that they have to be the same. So 4x minus 12y equals 8. To get y by itself, I'm going to subtract 4x from both sides. Don't forget your negative in front of the 12. Negative 12y equals negative 4x plus 8. Now I divide through by negative 12. And I'm left with y equals, well, negative 4 divided by negative 12 is a positive 1/3 x. And positive 8 divided by negative 12 actually becomes minus 2/3. And on the other side, if I subtract x from both sides, I'm left with negative 3y equals negative x plus 2. Divide by negative 3, and I'm left with y equals negative 1x divided by negative 3 becomes 1/3 x minus 2/3. So, I just want you to see that given an equation in standard form, we can put it in slope-intercept form, and we can find equivalent equations as long as whatever we do to one side, we do to the other. So as you can see, these are equivalent equations because in slope-intercept form, they're exactly the same. Okay, so keeping in mind our different forms, this time we have a line with 2 points marked on it. We don't know the y-intercept, but we can still write an equation of this line in standard form. So before I get to standard form, I'm going to use point-slope form, because since I have 2 points that I know fall on the line, I can easily find the slope between them, and then I can use one of the points to plug it into point-slope form, and then I can move stuff around to write it in standard form. So first I need my m. Well, I'm just going to count. I go down 1, 2, 3 to the right 1, so that's negative 3 over positive 1. Negative 3 divided by 1 is negative 3, so my slope is negative 3. And I'm going to use that first point. So y minus 1 equals negative 3 times x minus 1. And now, to put it in standard form, I want to end up getting x and y on the same side of the equal sign. Before I can do that, I need to distribute the negative 3. So y minus 1 equals negative 3x. Negative 3 times negative 1 is plus 1. And now I can move that negative 3x over. So I can add 3x to both sides. So I end up with 3x plus y minus 1 equals positive 1. And now to get it fully in standard form, I need to move that minus 1 over. So I'm going to add 1 to both sides, and I'm left with 3x plus y equals 2. And notice, that's of the form ax plus by equals c. And in this case, even though there's no coefficient next to y, remember that means there's an implied coefficient of 1. So b in this case is actually 1. Okay, so we can write horizontal and vertical lines in standard form as well. So remember, we talked about Hooyvuks. So just like we can graph a line given an equation, we can look at that line and write the equation. So this is here to remind us that a horizontal line has to have an equation of y equals, and a vertical line has to have an equation of x equals. So first I'm going to look at my horizontal line. And notice there's a point marked on here at 2, negative 4. But that's just one point that falls on the line, right? So let's look at a couple others. This point right here would be 0, negative 4. And this point right here would be 4, negative 4. So notice they all have the same y coordinate. And remember, our horizontal line has to be written as a y equals equation. And since y equals negative 4, no matter what the x coordinate, my equation for that horizontal line is just y equals negative 4. Same sort of thing for the vertical line. Notice any of the points on this line all have an x coordinate of 4. So that's 4, 1, 4, 0, 4, negative 2. But they all have the x coordinate in common. So just like we can graph a line, again, looking at the line, knowing that it has an x coordinate of 4, our vertical line has an equation of x equals 4. Okay, so we know this equation, the equation of this line has to be ax plus 3y equals 2. So if we know that much about it, kind of like we did with slope-intercept form, we can use this point, xy, to solve for a, and then plug a back into the equation. So ax plus 3y equals positive 2. Well, I know x is negative 1 when y is 0. So now I want to solve for a. So negative 1a, well, 3 times 0 plus 0 equals 2. And that's the same as negative 1a equals 2. And to get a by itself, I'm going to divide by negative 1 on both sides. So I know my a, my coefficient of the x, has to be 2 divided by negative 1, which is negative 2. Now remember, we're being asked to write the equation in standard form, so I need to go back and plug it in. So negative 2x plus 3y equals 2. So that's my equation in standard form. And that's it for this section.